Hello everybody, welcome back to another edition of the Modicon M221. I'm your host Leandro Mada, and in this video we are going to talk about the Modbus TCP IO scanner functionality that we have in the EcoStruxure Machine Expert Basic. So let's go to the presentation. We are going to continue working with the application that we've seen in the previous video about the communication blocks for the M221. Okay, we're gonna edit the project and we are going to use the IO scanner. So most of the implementation or the connection is still the same. Okay, we just need to make some small adjustments on the configuration because all the communication blocks now are not needed. Okay, so the information we're going to read and write will be the same as we've seen before. We're going to read the analog inputs from the other PLC from the Modicon M172 over Modbus TCP, and we're going to write into the backlight of the controller so we can see that something is changing. So for the configuration of the Ethernet port, it's the same. We just need to specify the IP address and the subnet mask and gateway for the PLC, and it should be in the same network as the other device. Otherwise, there's no communication at all. So we already know how to do that. Okay, and I'm going to go into details over that. What is changed is this part. So what we need to do basically is to add the device, okay, over here, but what we need to do is to click on the enable Modbus TCP IO scanner in order to activate that part. So if we continue with this, it will allow us now to select if we want a drive or we want a predefined device, okay, and you have the list over here, okay, in order to add any other device. For example, if you want to connect to a bus coupler, we just need to use this one. If you want to use a drive, we just go into that settings, okay? But we are going to focus only in the generic, okay? So once you define the device, once you add the enable, define the IP address, select what you want, you just add it into the table, as we have done in the past, okay? Then you should be able to change the PLC name, the name of the device that you're going to communicate. The IP address is already defined, but you can change it. And then there are two specific fields to configure, the init request and the channels. So the init request allowed us to pre-configure something on the other side, okay? So you can define which position of variables or memory address that you want to pre-configure on the other side, okay? And then you have the channels. Uh, I just jump a little bit. If you click over here in the init request, okay, you just specify which information you want to add into the communication, okay, and it's the same functions of the models that we're going to see later, okay. It's just for pre-configuration. Now then you have the possibility to edit the channels, okay, to directly connect to the other side. So if you click over here in the channels, then you can add all the channels communication that you want to establish. But we're going to focus that later, so don't worry about it, okay? So if you add the channel, okay, you have the possibility to configure it. So in the configuration for each channel, you need to specify the message type that is related to the Modbus function, as you can see over here, of the functions that are available on the IO scanner. Then you should be able to select the trigger because you can specify to be periodic. Okay, you have a cycle and you can define the cycle. Okay, or you can define a variable memory bit in order to trigger that execution of the sending or received information to the other sides. And then what you need to do is to modify this part, which is the read and write information that you want. So you have the offset from the other side, the percentage NWU or IWU on the other side, and then the amount of information. Okay, so this part is very similar to what we have seen in the communication blocks, that we have defined first the IP address but it was linked to the index that we have. And then we should select the message type of object type that we saw on the communication blocks, which is the Modbus function that we are going to use in order to communicate with the other device. And then you will need to specify from which direction do you want to read or write the data, and then how many words do you want to read and write. Okay, so far here is the same. What is missing at the moment is where I can read that data from this IO scanner and put it in my code in the PLC. Okay, so if we continue with this, you can see here all the functions that we have for the M221 in the IO scanner, and this one is is are the Modbus functions. Okay, that we can use in most of the devices. Okay, and this one is the one that we can use. So what we need to do is to check on the other side. Okay, for example, in the PLC M172, which of these function codes are able to use. Otherwise, we're going to have an error, as we have seen on the previous video using the communication block. So what we're going to do now is to configure all this data, okay, on the in the software. So I'm going to open here. Let me just open this. Just hold on. So we have already configured the IP address for the PLC N172. Okay, now we just need to enable the Modbus TCP. One is enabled, we just need to go to init request, and here you can add a message type, okay, in order to write information. But in our case, it's not needed. So I'm going to leave it empty. What is important here is the channels, okay? So here, something important here, sometimes you just need to change this, which is the unit ID. Okay, so if the other device needs to change this to one or to another, this is where you need to change it. Okay, so let's go to the channels now. So what we need to do is to add two channels. Okay, one should be for the analog input, so it should be I01 analog input 02. I'm going to add another channel over here to be the just hold on. The display backlight. Okay. And now it's time to configure each of these channels. So analog input, configuration. Here I'm going to read. So I'm going to read multiple words. Percentage %NW. I can add a comment here and 172 analog inputs 01, 02. Okay. The offset will be the position on the other side. We have discussed this in the past. Okay, if should be this one. If I open the other software, okay, here you can see the positions, and I already explained why I need to subtract one. Okay, on this one, 8335, 8336. Okay, and I need to restart from the 8335. Okay, so this configuration is done for the analog inputs. Now let's start with the writing. Here is a little bit different. Instead of reading, we just need to write single word. So here the offset would be 8719. Okay. And let me just put some information. Backlight. Okay, so this part is done. Okay, so this is how you configure how you want to communicate with the other device, define it, the positions and the way if you want to read and write. So this is very simple. Okay, it's much better than using the function block, so you can see everything in one place, and that's all. And you can also specify the logic if you want to trigger with a variable or just want it to cycle. If you can see over here in the channels, I have already specified cycle, but if you want, you can use a %n variable to trigger the communication, but I'm not going to do that in this case. So Let's OK, and let's go to the presentation so we can continue and have further explanation. So this is what we have done. Now what we need to do is to check that information, because when you create the IO scanner, it generates an internal memory variable position, okay, where you can read and write that information. So if we go to the programming tab, okay, and select network object inside the tools, we can see that we have digital inputs, digital outputs, input register, output register, and between brackets the IO scanner. Okay, so the information that we use in the IO scanner will be located over here. And if we go to inputs register, input registers, you can see the percentage IWN, which are related for the reading from the other side, and the output register, the IO scanner, they are related to the percentage QWN 300. Okay, so here is the information that we are reading from the other side. So what we can do now is to assign to these variables a name, okay, so we can use in our code the symbol rather than the position, because probably it's a little bit complicated to remember all this, so it's much better to assign a symbol here. So this is what we're going to do now, okay? So let's go to the application. Okay, good. Let's apply this. So we just need to go to programming, tools, okay. Here, system objects, no, net, my bad, network objects. Here you have the IO scanners, okay. Input register should be 2, okay, for the analog input. And you can see here the name of the channel, so you can identify and you don't need to guess. So it's important to name the channel that you have. As you can see over here, channels, it's important to name it so it's much easier to identify it. So here, input register symbol, which has assigned N172 underscore 01 and 172 underscore I102. Okay, you can assign comments, and I'm going to do it, but you can, and I recommend you to do it. Output register here is the symbol N172 backlight. Okay, 0 off and 1 on. Okay, that's good, and apply. So in this way we have already defined all the variables that we want to read and write, okay, and it's the same on this part. Remember in the function blocks, okay, so far we have configured all this, and the index data in this case will be these two positions, okay, simple as that. So if we go now to IO scanner, a table, here is for the IWN 100 and QW 100 is for the serial line. Okay, so if we add the number 3 for 300, it should be for the port. Okay, port 3. So here I'm going to change this. We're going to see that later what is the IWNS, okay, which is related to the just to check the status of the channel, okay, but we're going to cover that later, okay. So if we go, let's save this first and continue with the presentation, okay. Now so in order to check if we have the communication, there are some internal variables inside the system of the PLC, which is the percentage SW212, okay, that allows us to see the status of the IO scanner. Okay, so if we go to, just hold on, here, percentage SW212, it allows us to see the IO scanner or the status of the IO scanner of the Ethernet port. Okay, so in this way we can identify if there is a problem on the PLC IO scanner. Okay, so now how we can identify we have a problem is very simple. Let me just go back to the presentation. So if this value is 0, it means that it's a stop. The idea it should be the number 2, which is operational, and sometimes you can have the partially operational where there are some devices that are not connected. Okay, so we are going to see how we can reset this later. Probably I jump into this. Let me just quick show you this. So this variable percentage SW212, okay, can be found in the system object, system words, 212 here. So here you can check the status, and if I know wrong, there's another one to reset the IO scanner. Let me just double check. I totally forgot. Should be a system bit, my bad. And in order to reset that, we have these variables, this one and this one. Don't need to suspend and reset, but we're gonna cover that later. I just jump into that, my bad. So now we have the possibility to check the IO scanner, okay, as a whole, okay, if everything is fine or not on the PLC side. But now we also have the possibility to check the status of each channel. So how does it work? So depend on the table that we have in the application. In our case, we have defined this only, but if we add 2 more devices, okay, if we go to the IO scanner status, okay, we should be able to see this. We have the IWN 300, okay, that start for the first element that we have over here, starting with ID. And then the next element, the status of this device in the IO scanner, will be the 301, and the other one should be the 302. Okay, so this is how you can identify or find the status of each device. Then, if you have defined channels inside each device, you should be able to find the status of each channel. So, how does it work? So, it will start with the IWN 300 and then the index, okay? So, if it's the first element, it should be 300, okay? Otherwise, it should be 301, as you can see over there. And then you have a point, and the point and the next number is related to the ID that you have for each channel. So in our case, the M172 should be the channel, and you have these 2 channels. So the 0 will be for the analog input, and the 1 should be for the display backlight. So if we specify the IWN S 300.0, which should be related to the analog input, the first channel, and .1 should be for the second channel, related to the index. So this is how you can check in your code if you want, if you have a problem on the device and if you have a problem on the channel. So you can make some kind of diagnostic in case you have a problem in the communication. This is how you should operate this. Now let's continue with this. Okay, so now in order to check the devices, the idea is to be should be the number 2. The device is present and ready to be scanned. Okay, so if the device, the IWN 300 or 30X is in number 2, everything is all right. Okay, then for the channels, okay, if the value is 0, everything is all right. Otherwise, you should check the communication errors list, okay, to check what's going on. So what we're going to do now is to name these symbols. So we can get access to this. Let me just go to the software. Just hold on a minute. Okay, and now here. So we just need to go to System Objects, IO Scanner Status. As you can see here, the device's status. So this one should be for the device. So M172 communication status. Here M172 communication channel analog input, and 172 communication channel display. Okay, so here, if this one is 0 equal okay, 2 equal okay, 0 equal okay, and 0 equal okay. Okay, because these one are the channels. This one is the device. So we can apply this. Okay, and add this on the same animation table. I have already done it. Okay, you can see over here. Okay, so now what we can do is to connect with the PLC and see what's going on. So, no, before doing that, what I'm going to do is to add these the bits for the IO scanner so we can reset and everything. So it should be the 112 to reset and the S115 to suspend in case we want to suspend the communication. So let's connect now. Connect with the PLC. I'm just going to check with you that I have the 172 already connected on the network. Okay. So PC to controller. In this case, I'm leaving the function blocks because I didn't want it to change it, but it's not mandatory to have it, so you can delete it from your logic. Okay, I just leave it because I want it. So let's just play with this and go to the communication and see the communication table. So here you can see that I just download the application and I'm reading something, okay, which is good. So let me just show you this one. Okay, let's see if it's working. Okay, it's working. So what I'm going to do now is to change the backlight. So if we just send the command 1 over here, you can see the backlight is 1. Okay, and if you want, you can use this symbol in your logic instead of using the QWN. Okay, simple as that. So if I touch the proof, let me just open the other software. Okay, this one should be the proof, the sensor, temperature sensor. Just show you this should be the same as this one. Okay, just touching this, and probably the wrong command. Oh, there we go. So you can see that reading the same information and everything works fine. So if you want to suspend the communication, we just need to suspend over here. As you can see, there is nothing that I can read. Backlight, sending 1, nothing. Okay, it just doesn't work. And you can see the communication is in 4, so this is not in 2. This one is not in 2. Okay, and now here, if I set to 0, okay, it's working again. Now what we can do now is to going to disconnect the Ethernet port. Okay, so you can see that it's not working. Let me just disconnect from the other side. Okay, I disconnected from the PLC software. I'm going to disconnect this. So it's disconnected. You can see the status is number 3. Okay, now I'm going to connect it again. Okay, just checking if I return the communication. Okay, so what we need to do is to reset the communication over here, initializing, and then you have the communication once again. And that's it, simple as that. So what we have seen now is how you can use the IO scanner, which is a nice feature to make the things more easier. So you can see here that all the function blocks that we have in different ranks, more variables in order to make the logic to execute the function block, blah, 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 blah. You can simplify that by using the IO scanner to just define the table, the channels, the variables you want to be in one place, and that's it. Okay, so if you need to communicate with a device, I recommend you to go in the IO scanner rather than the function block. So um, this is the Modbus TCP IO scanner for the Modicon M221. Thank you very much for watching this video, and I see you on the next one.